Today on Engineering Newswire, we're controlling robot arms with our eyes, sketching massive prototypes with the Proto Piper, and designing aircraft that can withstand hypersonic flight.
A group of researchers at the Hasso-Plattner Institute's Human-Computer Interaction Lab have created a handheld fabrication device that allows users to sketch room-sized objects at their actual scale. Aptly named the Protopiper, the device forms adhesive tape into tubes which serve as the device's main building material. The tape tubes are much lighter than extruded plastic or photopolymer lines would be, which makes the tube suitable for large structures. The device itself works as an assembly line. The tape is drawn from the roll, shaped into a tube, and sealed together before being cut with a wing connector. According to the researchers, the Protopiper's tubes also allow users to create simple mechanisms. For example, by creasing the tubes, users can form hinges which allow for moving mechanisms, like this opening and closing umbrella, that serves absolutely no purpose. But it does allow designers to get a feel for the size in a space and, well, just to have some fun.
Scientists from Imperial College London have developed computer software that allows a person to control a robotic arm to paint using only their eye movements. The researchers believe their technology shows how robots can give people a second pair of hands. Instead of following a set of computer commands, the robotic arm is guided by a tracker that follows the direction of the eyes, with an algorithm translating the path of the user's gaze into commands that control the robotic arm. For example, if you want to paint a straight line, you would just look at the starting point and the ending point, and the robot will paint the line. The researchers explained that if you want to choose a color, you need to blink 3 times, and then you look at the color you wish to select. Once selected, you blink 3 times again, and the robot will bring the brush back to the canvas. Pretty simple, right? Although the finished paintings are quite rudimentary, the demonstration shows how the technology could allow people to extend the human body with additional limbs. This could mean anything from doing the dishes while talking on the phone to helping those who suffer from debilitating conditions like multiple sclerosis or Parkinson's disease.
The US is once again in the supersonic aircraft business, looking to revive efforts to build high-speed aircraft that are capable of flying smoothly and efficiently through shockwaves. The Air Force Office of Scientific Research has issued a $900,000 grant to study how air behaves when traveling faster than the speed of sound. The lump sum was handed to a team led by Assistant Professor of Aerospace and Mechanical Engineering, Jesse Little, of the University of Arizona's College of Engineering, to fund the investigation of 3D shock boundary layer interaction, a combined approach using experiments, numerical simulations, and stability analysis. It's a long one, Mr. Little. It's a long one. Well, it is a mouthful, but the study focuses on understanding the physics of shock waves and how they interact with near-surface airflows in 3 dimensions. The research could help engineers design hypersonic aircraft like the US Air Force's X-51A Wave Rider, the unmanned scramjet demonstration aircraft that could travel at Mach 6, which is about 4,000 miles per hour. One long-term goal of the project is to develop guidelines for designing aircraft that can better withstand the structural and heat stresses of sustained supersonic and even hypersonic flight. It's fast. That is moving. 4,000. A good clip, my dad would say. A good clip. Comment below. We'll cover them in the next episode. If we get to it. This feels good.